All right, so we're going to go over some exponential growth and decay today. So remember exponential equations? Any exponential equation is an equation that follows, okay, the formula y equals ab to the x. All right, a is always the initial amount. All right. B is referred to as our growth factor, okay, or decay. All right, and x is usually referred to as our term or the amount of time. Now the growth and decay factor B is equal to either 1 plus or 1 minus r, which r is the rate. And that's expressed as a decimal, a percent. Okay? So in exponential growth, it's a is equal to 1 plus r to the t, and in decay, it's 1 minus r to the t. So that's where the 1 plus r, 1 minus r comes from. The compound interest formula for money is P, which is principal, is equal to 1 plus r, the rate, divided by n, which is the number of times you're compounding the interest in 1 year. And then that's raised to the n times t, where n is the number of times you're compounding it, and then t is the amount of time. So for the first example, we bought a new car for $25,000. It depreciates, so it goes down. So we're using our exponential decay formula. Okay, 12% per year, that's 0.12. You just take 12 and divide it by 100, and then in 5 years. So it's 1 minus 0.12, which is 0.88 to the fifth, and then we round to the nearest dollar. All right. For investing, and it's compounded monthly, that tells us that n is equal to 12, because there's 12 months in a year. Okay, the rate is 2.5%, which is 0.025 divided by 100. And how much will n is in 20 years? So that means that x, or t, right, is equal to 20. So the initial amount was 5,000, 1 plus r, 0.025, or 0.025, over 12 to the 12 times 20, and then we get our amount. All right. So if you take a look at number 332, which is in your packet too, by the way, his car depreciates at a rate of 19% per year. The value v after t years, which can be bounded by the function, which is equivalent to the original expression. All right. So one way to easily kind of do this is to actually figure out what this is equal to and figure out what these are equal to, and then you can choose the appropriate expression. So now another way to think of this is 0.81 is equal to 0.9 raised to what power? Okay, 0.81 is equal to 0.9 raised to what power? So if we grab the calculator, we can do 0.9 squared, and you see we get 0.81. So technically, we can think of this as 0.9 squared. So when we do the formula, it's 15,000, okay, is times, and we're going to do 0.9, and it's squared, right? And then it's also times t, because the t was originally there, and now we're doing 0.9 squared, so it's 2t. So that's why the answer is choice 2. 339, Dylan invested $600 in the savings account, 1.6% interest rate, no deposit for 12 account for 2 years. So we know that A is 600, our R is equal to 0.016, no deposit withdrawals for 2 years, so that's T, and it was compounded annually, so N is equal to 1. Okay, so we're just going to do our thing. P, right, is equal to 600, and it's getting more money, it's appreciating, so it's 1 plus R, 0.016, okay, raised to the N, which is 1, times T, which is 2. And so we're going to grab our calculator. All right, we're going to do 600 times 1 plus 0.016 raised to that. We're going to press the caret button, and then it's just 1 times 2. And there we go. We get $619.35. So P equals $619.35. We're rounding to the nearest penny here, so the nearest cent. All right. So we're rounding to the nearest hundredth. And that's how we do that question. 352. Some banks charge fees. The equation 0.98t represents the value and the left inactive for a period of X years. What is the y-intercept of this equation and what does it represent? So the y-intercept should be the initial amount, okay? At when X is equal to 0, that means I have no years, okay? That's what happens when I'm at some point on the y-axis. It's 0, comma, some y value, okay? So if I plug 0 in for X, this whole thing right here is just going to become 1, all right? So the y-intercept is 5,000, and it's the amount that's initially in the account, so it's choice 3. All right, 353, 1,350, and then 1.017 raised to the, looks like 4. Your sheet might be a little bit clearer. Let's see. It's T. Okay. T represents the value 2 years, okay, after its purchase. The yearly appreciation of the comic book is. So that we're asking for the rate. Now remember, this is B, so B is equal to 1 plus R here, okay, because it's appreciating. So if this is 1.017, essentially it's just the number attached to the after the 1, okay. So in this case, if we just 1 plus R, we subtract 1 and we get 0.017 equals R. If it's a percent, that means we're moving the decimal spot 2 spots back and we get 1.7%. Now, if this number was less than 0, right, let's say it's like the last question, or one before it, I think it was 0.88. So in this case, it would be is equal to 1 minus R, right? And I would subtract this from 1. So it's really the difference from 1. How do we get from this number back to 1? That's the rate, okay? So here this is negative 0.12, and that's equal to negative R, and then we can divide by negative 1 and get 0.12, or 12% is equal to R. So if it's less than 1, then it's the rate is the difference between 1 and that number. It's always 1 and that number, so just keep that in mind. I shortcut that process there. All right, on the next page. All right. You take a look at a couple other questions here, maybe. Well, that flips over, okay. Evaluating exponential functions. So if we have a computer here that generates the sequence of musical notes, where n is the notes and f of n is the frequency, which function will generate the same note sequence as this? So this is the same thing. What we want to do here is essentially look at the number inside the parentheses, okay? And how can we rewrite that number as one of these numbers instead? So if 16, I can write it as 4 to the second power, or I could write it with a base of 2. So if I write it with a base of 2, think about it, 2 times 2 is 4, so that's squared. The third power would be another 2, so that would be 8. And to the fourth power would be 16. So these are both equal to that 16. It's just another way to rewrite that number with a different base. Okay, so if I was going to keep it the same, I want f of n. This first number should not change. It should still be 6. Okay, and then this is going to change to either 4 squared, right, times n, which this just becomes 2n, or it's 6 times 2 to the fourth times n, and this is going to be 4n. So you can see how we have 2 to the 4n, and this 12, it tells us it can't be that one. And here it's another 12, and it's 2n. And here it's 8 and 2n. So we know it can't be 8. There's no way for me to multiply 8 times 8 and get 16. So it's got to be choice 2. All right, 334, which expression is equivalent to p sub t? Also, with 331, you could always just plug a number in, right? If I want to say to myself, all right, we're going to do it after like 5 years, I can do 6 times 16, right, to the fifth, and get an answer, and I better get the same answer. So if I try 12 times 2, right, to the 2n is 2 times 5, I better get the same answer, right? And you can see, like, I don't get the same answer. So just plug a number in, it would make sense, and see if you get the same answer. If you get two that have the same answer, just try a different one. And then eventually you'll find one that does not work. The other option is to check the equations, right? If you look at the equations on the graph, the equations should match. Okay, so just a new document real quick. We'll go to a graph. All right, this is 6 times 16 to the, instead of n, we're going to use x. So I get a graph that looks like this. Remember, we can zoom out, zoom, we can go to fit. It'll kind of zoom out for me. All right. Oh, you know what? That's why. Tab up. This is supposed to be to the x. Okay. And then we can just try the next one, right? If we try, let's say choice 4, 6 times 8 to the 2x. So tab 6 times 8 to the 2x, right? You can see that's not the same graph. The graph is off. So that's how we know that those aren't going to be the same thing. All right. Number of bacteria grown in the lab can be modeled by the equation there, which is the same as this. So if you think about it, what is 2 to the 4th, right? 2 to the 4th is 2 times 2 times 2 times 2. So this is 4. There's another 8, and then that's 16. So 2 to the 4th is 16. So it's equivalent to 300 times 16 to the t. All right. To do an exponential regression on your calculator, you're essentially just going to follow the process here. So it's just like doing a linear regression, except we choose exponential. So just a quick recap, we're going to go to our distance spreadsheets. We're going to name our coordinate, okay? And we'll pick, let's say 1, 2, 3, 4, 5. And let's do something that is going to be exponential. Let's say we did 2 to the x. So 1 is 2, 2 is 4, right? 3 is 8. We double it again to get 16, and we double it to get 32, okay? So if I want to get the equation that is modeled by this data, and I know it's exponential, what we can do is we can import a graph. We can do data and statistics, and I can choose my variables, x and y. We can actually see the curve here, right? You can see that it models up. So we can go to Menu, Analyze, Regression, and I'm going to go to Show Exponential, and there's my formula, 1 times 2 to the x, okay? So that's a way to get it here. On this page, you can do the same thing. Menu, Stats, Stat Calculations. We're going to Exponential, which is choice A, and then I'm just going to choose my axes here. Okay. All right. And there's my AB to the x. So A is 1, B is 2. So that's 1 times 2 to the x. Okay. And you can see the R value here is 1, which means it's a perfect regression. It's fixing up, and the residuals are 0 because they fit right on that line. All right. So that's it for this one, guys. And then we'll see you guys tomorrow.